What is going on, everybody? Nav here, and today we're going to talk about RxJS. In particular, what is the difference between ConcatMap, SwitchMap, and MergeMap? So let's get started. So the very first thing you need to understand about RxJS is a way of handling asynchronous programming, typically used in Angular, but can be used in other frameworks and libraries as well. And it allows us to pipe data into a stream and then create subscriptions or observables which we can listen or share that data. Now, RxJS itself will provide you a data stream, and I'll go more in depth on that in another video if you want to know more about the basics of RxJS. It's used for state management, local state management. In this tutorial, we're going to talk about SwitchMap, ConcatMap, and MergeMap. So let's take a look at this stream of RxJS data. So typically, I'll even space them apart to show that the data points are coming in at different sort of rates. And you'll sort of see here a nice visual. And this is sort of our data stream, right? This is our data stream. So the data comes in, and now I want to talk about the difference. Let's start with MergeMap. Actually, to make things easier, let's start with MergeMap, okay? So MergeMap in particular, if we were to apply MergeMap to this stream, all the data would go into the MergeMap as it comes in no particular order. So MergeMap will complete all operations on the mapping with no order guarantee, okay? And why this is important in particular is there are going to be scenarios where you want to get an operation done really fast, but you don't really want that operation you don't care about the order. Maybe it's a collection of objects. Maybe it's just a data set. It's not an array. The order doesn't matter, but we want to guarantee that all the operations on that pipe complete. Then we would use MergeMap. On the flip side, let's grab our diagram here and pull it down, and let's look at the example with ConcatMap. So I'm just going to go ahead and get rid of these extra arrows here, and we're going to look at ConcatMap. Now, ConcatMap, what it's going to do is it's going to create this array, and I actually want to go ahead and number these guys 1, 2, 3, 4, 5, and 6. And what it's going to do in our array here is it's going to receive these operations the same way that MergeMap did as they come. However, instead of just applying them to sort of a promise all. So you can think of this one kind of like a promise all, right? Like a promise all kind of, right? This one will throw them into a queue. So this one will guarantee that 1, 2, 3, 4, 5, 6 happens in that order. So order guaranteed, right? So this one has order guaranteed and will complete all of the operations. So essentially, both of these, ConcatMap and MergeMap, will complete all operations. Okay, and now let's take our same data stream example here, and let's look at SwitchMap, because SwitchMap is a little bit different. So in SwitchMap, it'll drop the current operation if not completed for the most recent or current operation. So think of it like, I'll give you a good example because this one seems to be the hardest to wrap our heads around, and then we'll take a look at some code. So think of it like a user is searching something, right? If I'm searching something in this search bar here and I type in like nav is, okay, now my SwitchMap is going to perform the operation of looking up this query in the back end, let's say. But then the user immediately cancels it and says, you guys are awesome, right? Well, even if that other call was not completed, it'll drop that operation and start this operation. That's why this is super valuable. It'll receive the new value, and essentially, let's say if it's still processing 1, it'll stop processing 1 and start processing 2. But if 3 comes in before 2 is done, then we'll stop processing 2 and start processing 3. Obviously, in this case, if 3 and 4 are coming in at the same time, then both will be stopped. Both operations would be stopped. But let's say 5 manages to complete. So 5 completes. Then we'll move on to 6. So maybe only 5 and 6 complete because this time, or let's say this time period, is long enough to complete this operation before the 6 comes in. And that's where SwitchMap is super valuable. So these are the differences in terms of a diagram or conceptually. Now I want to take a look at these differences in a code. Okay, so now let's take a look at ConcatMap specifically, and then we'll look at the other two. So here I'm setting up a stream of data and I'm console logging that stream. But now let's go in and change that a little bit. So let's pipe that stream and let's run a ConcatMap operation on it. And additionally, I'm going to add a delay of 500 milliseconds. So in the ConcatMap operation, we're just going to have some inner data here. And basically, I'm going to return a stream, which is the of value of that data. So this will be each of the data points. Now, because there's a bit of a delay, let's make this actually a bit longer. Let's do like 1300 milliseconds. And you'll see all the operations complete in one shot. That's because the delay is actually on this outer pipe, right? So the delay is going to be after the ConcatMap operation itself. But now, what if we actually go in here, we subscribe, or we pipe, let's pipe this inner operation inside of the ConcatMap. Now let's add this delay. So we'll add a delay of 500 inside the ConcatMap, and you'll see that what it'll do is it'll receive these objects in order, and it'll throw them into a queue, which is all in order. And we see that happen here, right? So now let's look at MergeMap and the difference between the two. MergeMap, flat map, same thing. If we run MergeMap, if I make this delay a little longer, let's say 3 seconds, 1, 2, 3, and then we see all the results, because MergeMap is basically, there's no queue. Think of it more like slapping them all into an object. So it could be in whatever order. Order is not guaranteed in any way when you're doing a MergeMap, right? So in this case, we receive the items in order, and it just so happens that this delay processes slightly before the next value. But let's say this wasn't a delay. Let's say, I don't know, let's do if we did a math.random, you know, multiply it by 1,000. So that could give us, you know, and you notice how the order is different. But if I make this a ConcatMap, it doesn't matter the delay that gets applied. The order remains the same. It will wait until this operation is done before completing this one. Whereas with a MergeMap, because you can see how if you have asynchronous operations, you'll get a different ordering each time. And it all depends on how long these asynchronous calls. So like these could be async calls in here, right? With each value, right? Example, fetch by ID, right? And you'll get, I mean, that time we got almost lucky enough to get it in order, but not quite. And so this is a great example, actually, of the difference between ConcatMap and MergeMap, right? So ConcatMap, you're guaranteed the order. It will wait. It'll queue them up. MergeMap will just do it all. Doesn't matter. We'll like just all at the same time, fire it all. Now let's look at the last one, which is SwitchMap. Now this one's a little trickier. However, I think you guys can wrap your head around this. In the switch map, we noticed that only the last operation was complete, and that is because the previous operation did not have enough time to complete before the next value of the stream entered this pipe. Therefore, it dropped its operation. It dropped, it couldn't complete this delay. It just went on to the next thing. If I remove this delay, we get all the values because there's no delay. It's not waiting for the call. The call completes instantly or very, very rapidly. And then but if I add the delay, there's the next value comes into the pipe before the previous operation can complete. So I hope this helps you understand the difference between SwitchMap, ConcatMap, and MergeMap. And if you like this video and you want more like it, make sure you subscribe and like the video. Make sure you leave a comment for your favorite RxJS operator, and I'll see you in the next one. Goodbye.